In this video, we're going to talk about a slightly more complicated but more normal or more regularly used interest account, compound interest. So in a compound interest account, interest is earned on the principal amount as well as on previously accrued interest. So once you start accruing interest, you get interest on top of interest. Okay, so we need some more extra terminology. So the compounding period is the amount of time until interest is applied to the account. So for the simple interest, it was always annually, but here it could be less than a year or more than a year. Okay, the compounding period can change. And M is going to be the number of compounding periods per year. Okay, so for example, if it's compounded monthly, then M would be 12. Okay, if it's compounded, let's say semi-annually, okay, that means twice per year, so the M would be 2. Okay, so just 2 examples there. Then the interest rate, R, is always given as an, they call it nominal or annual interest rate. So when you compound more, you don't get that rate every time. You actually get a portion of the rate each time. So when you have a compound interest account, you need to use the interest per compounding period. Okay, and so we call that I, and it's going to be the old interest rate, the annual interest rate, over the number of compounding periods per year. Okay, so this is the annual or nominal interest rate. And then this is the number of times per year, the number of times that you accrue interest. Okay, so that's how you find your interest rate per compounding period. So let's do an example. So we're going to deposit $100 into an account, and the annual interest rate is 10%, but it's compounded quarterly. Okay, so that's just so we know that our P is going to be 100. That's our principal. The annual interest rate is still the R, so 10% is 0.1. And compounded quarterly means that our M is going to be 4. So it's going to happen 4 times per year. So if we want the interest per compounding period, that's I. It's going to be R over M. Okay, maybe I should put this in a box so you can find it. So it's going to be 0.1 divided by 4. Okay, which here is equal to 0.025. Okay, so now without the formula, okay, we're going to try to come up with how we would compute the compound interest amounts. So we're going to do it by an example, talking about just the first 4 compounding periods. Okay, so at the beginning, after 0 compounding periods, I'm going to call that A0. Obviously, no interest is applied yet, so this is just going to be our principal, which is $100. Okay, so we haven't done anything yet. After 1 compounding period, we have no accrued interest. Okay, so the interest that we get is all going to be on the principal. So we can use a simple interest formula. So this is P times 1 plus R over T. Okay, so we're using here the simple interest formula. Okay, so what this is going to be is 100 times 1 plus, now r is 0.1. And t, because we're doing it, we've only gone a quarter of the year, t is going to be a quarter here. Okay, so t is equal to, a quarter of the year is 3 months, so it's 3 out of 12, or 1 over 4. Okay, so if you compute that, you end up getting $102.50. Okay, but what I actually want to look at is, what does this look like? So let's just write this in green maybe. So this is also 1 plus 0.1 divided by 4, or 0.1 times 1 over 4 is 0.025. So notice that this part, this is I. This is our compounding interest per compounding period. Okay, so then we could actually write this is equal, okay, 100 times 1.025. So 1 plus I. Okay, that's equal to this number. Okay, it's just a different way to write it. But I might use that form. Okay, so A2. So now we only have the simple interest account. So I want to use the simple interest formula, but I'm going to be applying interest to the amount that I've earned in A1. So what I'm going to do is still use the same formula, but my new P is actually A1. Okay, so it's going to be A1 times 1 plus RT. And again, T is going to be a quarter, because I'm going from the first 3 months to the 6-month mark. Okay, so that's only a quarter of the year. So this is going to be 102.50 times 1 plus 0.1 times 1 over 4. Okay, now if you compute this, you're going to get the number is 105.06. Okay, but what I actually want to write this in a different way. So let's do this in green. So 102.5 or 102.50, this is A1. Okay, so instead of writing it like that, let's just use a highlighter here. So I'm going to replace this with this. Okay, they're the same. So those are the same, they're equal to each other. So instead of 102.50, I'm going to write 100 times 1.025. Okay, and then in this bracket, this is 1.025. Okay, so this is this part. And this is this part. So what we see is I actually get 100 times 1.025 to the power 2, because there's 2 of them multiplied together. Okay, so finally, so I'm trying to get a pattern here. Okay, so finally for A3, our new P is going to be A2, and then we're going to multiply it by 1 plus RT. So this is going to be 105.06 times 1 plus 0.1 times 1 over 4. And again, if you compute this, you get $107.69. Okay, but what I actually care about is writing it a different way. So this 105.06, I can actually write, so let's use a different color here, so green. So this is actually that, okay, to the power 2. So that's what I'm going to replace it with. So this is 100 times 1.025 to the power 2. And then this bracket here is again 1.025. So what I end up getting is 100 times 1.025 to the power 3. And hopefully this is enough for you to see the pattern. I'm going to switch highlighter colors. Okay, so when I had A1, I had 100 times 1.025 to the power 1. There's no power there, but okay. When I have A2, after 2 compounding periods, I have the principal times 1 plus I to the power 2. When I have A3, I have 100 times 1.025, so the principal times 1 plus I to the power 3. Okay, this is actually what we're going to do to compute the formula, to find the formula. So how the formula comes is just from changing your p-value each time, because you want to apply interest onto the new amount that you have, because you're allowed to use interest on interest. So hopefully that convinced you. So the compound interest formula. So if you have a compound interest account and you deposit P dollars with annual interest rate R, compounded M times per year after T years. A is your future value. Okay, so what it's going to look like is P times 1 plus I to the power N. Okay, where N is equal to the number of compounding periods in total. Okay, so if you do for T years and you have M per year, N is going to be M times T. Okay, now if you want to write it with R's, okay, so I is actually R over M. So you could also think about this as P times 1 plus R over M to the power M times T. Okay, both of those give you your future value after T years, where you compound M times per year. So let's do an example. How much money will I have in 10 years if I deposit $5,000 into an account paying 6% interest compounded monthly? Okay, so my T is the 10, so it's 10 years. I'm depositing $5,000, so that's my P value, my principal. The interest, they always give me the interest as the annual interest. Okay, so 6% is 0.06. And it's compounded monthly, so my M is 12. Okay, so we might want to compute the I. So I is R over M. So that's going to be 0.06 over 12, which is 0.005. Okay, and the N is M times T. So that's going to be 12 times 10, or 120. So our A value, maybe I should move this up a little bit. So A is P times 1 plus, not R, I to the power N. So that's going to be 5,000 times 1 plus 0.005 to the power 120. So if you compute that, it's going to be $9,096.98. So that's how much I'm going to have after 10 years. Okay, so now I want to do another example where we change the compounding period to see what happens. Okay, so everything else will be the same. So I'm going to deposit, so my P is $500. The interest rate, the nominal interest rate is 12%, so 0.12. And the T is always going to be 3 years. Okay, and then what's changing is the R. Or the M, sorry, the M. Okay, so quarterly means that M is 4, so 4 times per year. So that's going to mean that my I is 0.12 over 4, which is 0.03. And my N is 4 times 3, which is 12. Okay, so here my A value is going to be 500, 1 plus 0.03, so 1.03 to the power 12. And here, after 3 years, we're going to have $712.88. Okay, what if it's monthly? So monthly means that M is 12. So I'm going to have to change I and N. So 0.12 over 12 is going to be 0.01. And n is going to be 12 times 3, or 36. So then my a value is 500 times 1.01 to the power 36, which gives me $715.38. Okay, so notice, slightly bigger. So I got I had more compounding periods, but everything else was the same, and I got a slightly bigger future value. Okay, now what if it's daily? Okay, so for daily, we always assume 365 days. Okay, so no leap years. Okay, so I'm just going to go right to the formula here. Okay, so A, because the numbers are really not nice. So it's 500 times 1 plus 0.12 over 365 to the power 365 times 3. Okay, now if you compute that, you get $716.62. Okay, so again, slightly bigger. So the note here is when everything else is the same, more compounding periods per year, so the higher M is, the more money will accrue. Okay, but not infinitely more. So there is sort of an upper bound on this. Okay, now in the next video, we're going to see how to compare accounts when multiple things change. So here we're only changing the compounding period. So you could do daily, you could do every second, you could do every millisecond, right? This can keep going. So sort of the upper bound on how many compounding periods we can do is we let the compounding period get infinitely small. Okay, so you're sort of letting the amount of time between compounding periods go to zero, essentially. So what we think of when we say that is we think of compounding continuously. Okay, so that's what we say. So here, okay, the M value is getting really, really big because we're compounding more often. So it's approaching infinity. Okay, so this is very large. So if you want A, it should be P times 1 plus R over M to the power M times T. So what's happening as M gets really big? Let's change colors here. Now you're not going to have to reproduce this, but I just want to try to illustrate this a little bit. And if you've taken some calculus, it might make a bit of sense. Okay, so as M gets really big, so as M goes to infinity, R over M, I'm going to have a number that's actually a small number divided by a really big number. Okay, if you try to do that on your calculator, so like 1 divided by a really big number, you're going to get a really small number. This is actually going to approach 0. Okay, so what that means is that 1 plus R over M is approaching 1 plus 0, or 1. Okay, now also M times T is infinity times a number. Okay, it's going to be a really big number. So what's happening is we have a P, okay, that's fine, a constant, times 1 to the power infinity. So you might think that this is 1, because 1 to any power is still 1. But because we're approaching 1 and the exponent is approaching infinity, it depends how we approach. So it actually, it matters. So we say that 1 plus r over m to the power mt. So this is approaching 1 to the infinity, okay? But this we call an indeterminate form. Okay, so it's hard to say what happens. Okay, but using calculus, which obviously we don't need to use here, but so I'm just going to tell you what happens. Using calculus, you can show that 1 plus r over m to the power mt approaches e to the rt. Okay, where e is a number. So it's like pi, it's an irrational number. It's 2.718218, and it just keeps going. So it's an infinite, non-repeating decimal. Okay, so it's an irrational number. Okay, but it's very special. It's called Euler's constant. Okay, but it's a number, and your calculator has a button for computing it. Okay, so this is what happens when we have what we call a continuously compounded interest. So we're going to have an e in our formula. So if you deposit P dollars into an account for T years with interest rate R compounded continuously, okay, so it will say that phrase, and then you'll know that you want to use this formula. Then the future value A is given by P times e to the RT. Okay, so that's when you want to use this formula. So this is the most you can compound. Okay, so let's just do that example we were doing it before again. So let me just remind you. Oops. So P was 500, R was 0.12, and T was 3. Okay, so if we did continuously compounded interest, our A is going to be 500 times e to the 0.12 times 3. Okay, so you want to be careful when you're doing this on your calculator. So if you want to do all of this at once in the exponent, you're going to want to do brackets around it. Okay, otherwise it's going to do e to the 0.12 times 3 after. Okay, so you want to put brackets. Or you can just compute that and then write it as e to the 0.36. Okay, either way, you should get $716.66. Okay, this is slightly bigger than the daily one, the daily total that we got, and it's the best you can do with all else the same. Okay, so that's the number of compounding periods is as big as possible.